In this video, we're going to take a look at degrees of freedom and the chi-squared family of distributions. Now, in the previous video, we started to lay the foundations here for chi-squared tests with goodness of fit and calculating the test statistic, which is our chi-squared value or the x-squared value that you can see here on the screen. What we're looking to do now is expand on this and prepare ourselves for hypothesis testing by looking at degrees of freedom and the chi-squared family of distributions. Now, generally speaking here, degrees of freedom are calculated from the sample size, and they are a measure of the amount of information that hasn't been used up. So therefore, every time we calculate a statistic from a sample, we use up 1 degree of freedom. So starting off then, let's say we have n observed frequencies here. Well, in that case, our model must also have the same total frequency as our observed distribution. And we class this as a constraint, and it is used in calculating the degrees of freedom. Now, for example, let's say we roll a 6-sided dice 200 times. Well, there are 6 observed frequencies here because we can get 1, 2, 3, 4, 5, and 6. And we have 1 constraint here. That is the total number of rolls. Well, for the number of constraints then, this can also change depending on our distribution and whether the parameters are known. So if a parameter is unknown and we estimate this based on our observed frequencies, we class this as a constraint. And it's also important to note here that we refer to the rectangles of our table that contain data anyway as a cell. So sometimes we may have to combine cells. Now, we combine cells when our expected frequencies are below 5, and we'll see why this is the case in a moment on the next page when we look at the chi-squared family of distributions. So to summarize then for this page here, so to calculate the degrees of freedom, as we can see here, so the degrees of freedom is equal to the number of cells after we combine here. So this is very important. We don't do it before combining. This is after combining here. And then we subtract the number of constraints. So in the case here of the 6-sided dice that we roll 200 times, well, as we noted here, there are 6 observed frequencies here, and we have 1 constraint. So the degrees of freedom would be 6 minus 1, and we would have 5 degrees of freedom there. Okay. So before we take a look then at a quick practice question here, let's just look at the chi-squared family of distributions. Now, the chi-squared family of distributions can be used as approximations for x squared here. So this x squared, this is our chi-squared value. So all I've got here is the mathematical equivalent of this sentence then. So this result especially should not be new to you. So this result we established in the previous video on goodness of fit, and this gives us our test statistic, right? So we do have one issue here. So as you can see then, however, we require that all of the expected values are greater than 5. If that isn't the case, what we must do is combine frequencies until they are greater than 5. So do be aware of this fact here. This is really, really important. Okay, so all of the expected values must be greater than 5. If not, we must combine frequencies. And then finally here, the way that we denote the chi-squared family of distributions is as follows. So what I've actually got here is 2 Greek letters. So the one that looks like an X here, so this one here, this is the Greek letter chi here. So it's not chi, it's not chai, it's chi. That's the Greek letter chi there. And then this letter here, this looks a little bit like a V. This isn't actually a V, this is the Greek letter nu. Okay, so nu there, nu. So again, another Greek letter. So the V, or, well, it's not a V, I keep calling it a V. It's not, it's the Greek letter nu. So nu here is equal to the number of degrees of freedom. Okay, so on its own, this doesn't look particularly interesting, but you'll see in a moment on the practice question how we use this. Okay, so that gives everything that we need here then for our introduction to degrees of freedom and the chi-squared family of distributions. Let's take a look then at one practice question. Let's just take a look then at this one practice question here. So what do we have for this question? Well, all it asks us to do is find the following critical values. And as you can see here, we are given 3 parts. We've got part A, part B, and then finally part C here. So let's begin with part A. So for part A then, what do we have here? Well, I've got a chi-squared distribution here. So we've got the chi-squared distribution where the degrees of freedom is equal to 3. So chi-squared with 3 degrees of freedom. And this is at the 10% level of significance. Okay, so how do we find this critical value here? Well, what we need to do is use our formula book. And what I've done then is took a snippet of the formula book here. So if you've got it to hand, do feel free to use your own version as well. But if not, feel free to use this version here to help you. So how do we do this then using the formula book? Well, the first thing we need is the degrees of freedom. So for the first example here, we've already mentioned it, the degrees of freedom is 3. So we're going to be in this row here then. Okay, so we're in this row here, and we're at the 10% level of significance. So what we need here is 0.1. This corresponds to the significance level here. So this one here is 1%, this is 0.5%, this is 2.5%, that's 5%, and then clearly here, this is 10%. So basically we just go along this row here until we get to 10%, which gives us this value here. Okay, so we get 6.251 there. So 6.251 there. And as you can see, it's as straightforward as that. So really nothing challenging here. It's just being able to basically find critical values for the chi-squared test here. Okay. So now let's move on to part B then. So for part B here, again, we've got another chi-squared distribution here. So we've got chi-squared distribution here where we have 8 degrees of freedom. So 8 degrees of freedom at the 5% level of significance here. Okay. So again, we just refer to the formula book here. Now the degrees of freedom is 8. So we're along this row here. Along this row here then. And we keep going down until we get to 5%. So this would be this column here. So we go along this row until we get to 5%, which gives us this value here. Okay. So we get 15.507 there. So 15.507. And then finally, we arrive at the very last part here, part C. So for part C then, what do we have here? Well, again, I've got another chi-squared distribution here. I've got chi-squared, this time now with 5 degrees of freedom. And this is at the 2.5% level of significance here. So 2.5% level of significance. Okay. So now we're along this row here because we have 5 degrees of freedom. And we keep going here until we get to 2.5%. So we go along, this is 10%, this is 5%, and this here is 2.5%. Okay. And now how so we get 12.832 there. So 12.832 there. And there we have it. So nice and straightforward. That gives us the solution there to our practice question. And that brings us to the end of this video on degrees of freedom and the chi-squared family of distributions.